We're going to cover question 4, part D of the 2022 AP Calculus AB free response section, no calculator allowed portion. So as we go through this, the other three videos I've done A, B, and C on, and then this is the fourth video in the series. So if you want to go back and see the answers for A, B, and C and how I went through those are in another video. Feel free to hit those up. Here we're just going to be talking about part D. So we start off with part D, and what happens on part D that you just got to kind of like bells and whistles got to be going off that something's different here is all of a sudden, for the first time ever in this entire problem, if you read through every other word on this problem, they never talk about the height of this. We're just talking about how this cone is changing. We're not really talking anything else about the height. And so right now you should say, well, that seems different. And then they're going to start talking to us about, okay, the height of the cone decreases at a rate of 2 centimeters per day. So all of a sudden they're talking to me about a rate of change going on with that height. And then as you read through the rest of this, you'd say, okay, at time 3, the radius is, and so now again, we're not talking about, the table up here is talking about r primes. This is really the first time we've talked about the radius itself. Then we're talking about the height being a specific amount at that point in time. And then the answer that they're looking for is wanting the rate of change of the volume of the cone with respect to time. So again, all of a sudden we're talking about volume here out of nowhere. So again, those should kind of be like, all right, something's different about this, and probably I'm not using much of that information from the previous work. So when we start talking about rates of change like this, that's really what you've got going on. This is probably a related rates problem. And in a related rates problem, kind of the first thing that I do is I start pulling out the rates that they're talking to me about. So they told us that the height is decreasing at a rate of, so rates are derivative pieces. So I would call this dH dt because it's how the height is changing, and the per day kind of tells me that I'm talking about time, and that's how I get the dt piece on bottom here. Decreases at a rate of 2 centimeters per day. So remember when they use words like decrease and increase in the language on something like this, that they're talking to us about a positive or a negative. So a negative rate means that, or a decrease means we're dealing with a negative rate. So dH dt is going to equal -2. And then I come through and I keep kind of grabbing the rest of this, and I would say, okay, well now they're telling me that the radius is 100 centimeters. So then I also know that r is 100. They tell me then the height is, notice that the height and the radius pieces right here aren't talking about rates of change. They're just talking about a flat amount. And so we don't want derivatives on that. We're just looking at flat amounts. So the height is 50. And then they're asking us to find the rate of change of volume with respect to time. So what they want out of us is they want us to go find dV dt at this specific time t equals 3. This related rates problem is nice because they actually give us the formula that we're going to need to use. We have one formula here that relates all of our pieces together, our volume, our radius, and our height. So we're going to use the volume formula that they gave us to find out what our answer is. Related rates problems are word problems that require us to do implicit differentiation to get to the answer. So what we would do with this volume formula here is we're going to wrap this in a set of parentheses, and we're going to ddt it. We're going to take the derivative with respect to time, because everything they talk about is with respect to time right here, and all of our rates are per day, right? So keep that in mind as you go through. That's usually what you want to do on a related rates problem, is ddt it. But if those units were something different than per day, or they said something other than respect to time, that would just be something to pay attention to. So as you come through here, you're going to take the derivative of each one of these pieces like you normally would. But I have a little saying when I do implicit differentiation, which is every time I take a derivative, I get extra stuff. And what that extra stuff looks like is kind of envision there being this little dotted box behind that D on top. And what you'll do is you'll fill that box in with the letter of whatever you took the derivative of. So every time you take a derivative, you're going to get your extra stuff, and you're going to get a D, whatever you took the letter of, over dt. So starting off with this first piece here, the derivative of v, normally that's just a straight up power rule. That would have been a 1. And then I took the derivative of a v, so I get a dv dt. I'm filling that little box in with a v. Coming over here, I'm taking the derivative of that whole thing. Well, when I look at this, that's actually two chunks being multiplied right now. So remember, as you go through these processes, that product rule, chain rule, all of our derivative rules still apply. So when I have two things being multiplied, that's when I need to follow my product rule recipe. So the product rule recipe that I have memorized goes f g prime plus g f prime. Yours might be slightly different, but they both will get us to the same place. You just need something that you can spit out of your brain like the back, like no problem anytime you're in the middle of a test. If you don't have a product rule recipe, you're in trouble. So as we do this, keep in mind that the g prime portion and the f prime portion, that's when we're taking a derivative, and that's when we're going to get our extra stuff. So what I would do here is I would kind of break this up into two smaller problems. So the f piece is going to be that front chunk, and the g is going to be my h. And I'm just going to kind of put it over to the side over here. So f is 1/3 pi r squared. G is h. So as I come through to take the derivative, I start off again, take the derivative like I normally would. All this stuff up in front there, that's just a number. So when I do my power rule, I bring the 2 down. I get 2/3 pi, subtract 1 from the power, gets me an r. And then I took the derivative of an r, so I get my extra stuff, right? I'm going to get a dr dt this time because I took the derivative of an r. Then I come to do my g prime, the derivative of h, just like with the v, that's going to be 1. You bring your 1 down in front, then technically you get h to the 0 when you subtract 1 from the power, but anything to the 0 power is just 1, so we don't need that. And then you took a derivative, you get extra stuff. You took the derivative of an h, so you get a dh dt. So I call that all my ingredients that I need to put together my product rule recipe over here. So now I'm going to put together my product rule recipe. Start off with f, so I go grab f. 1/3 pi r squared. Going to multiply that by g prime. G prime is 1 and then dh dt plus go grab the g piece. G is just h. And then we're going to multiply that by f prime, which is going to be our 2/3 pi r and then dr dt. So coming through here right now, when we go to plug everything in, we got to have values for everything. And so because you have to have values for everything, you kind of want to do a quick little mental check and make sure you've got a value for all your pieces. So you'd say, okay, I've got an r here, and then I've got an r value given to me. So check on that. Then you work your way through and you say, okay, I need a dh dt. They gave me the dh dt, check. I've got an h, all right. I've got the h up here, check. Again, there's the same r from before, so check. Oh, wait a second. Where am I going to get a dr dt from? Remember now, you'd say, okay, how do I find the derivative of r with respect to time? Well, dr dt is the same as r prime of t, which is this portion of our table from up above. So this was a little tricky part of this. This was probably the key to making or breaking this. Like if you identified it, this was a related rates, you could, and you done your practice, you could probably get this far. But this was where it kind of the rubber hits the road trying to figure this out. So now all of a sudden this t equals 3 that they've been talking to us about this whole time, now that starts to make sense because I need to know what's happening at 3. I want to know what r prime of 3 is. So r prime of 3 is going to be negative 5.0. So that is my dr dt value, is that negative 5.0. And so that's the last piece of the puzzle here. And now I've got everything I need except for the one piece which I'm trying to find, which is the dv dt. So from there, now we just begin the process of plugging everything in. So we get dv dt is going to equal, we get 1/3 pi, then we need our radius squared, so that's going to be 100 squared, and then we don't need that 1. dH dt, they're telling us, is -2. Plus, and then out of there, you're going to get h, which is 50 times, and then 2/3 pi. Then our radius, again, is 100. And then our dr dt was that last missing piece. That's going to be -5. You know, again, like this is where it's just kind of like miserable, right? Like you don't have a calculator and they want you to kind of put all this together. And it's not horrible, but you're definitely like in the middle of an AP Calc test, it's, you know, not always your favorite thing. But breaking it down, you know, 100 times 100, that's, you know, count up your zeros. That's going to be 1 with 4 zeros behind it. Times this -2 is going to get us, so for this first part, we would have -20,000 pi, and then all of that would be over the 3 that's sitting here. Remember, pi is over 1, so that would be sitting up top. Plus, and then working our way down onto this side, we've got 50 times 100. So 50 times 100 is going to be 5 with 3 zeros. And then multiply that by a -5, and now we're looking at -25,000. And then multiply that by this 2 on top here, and we're looking at -50,000. So the numbers are going to give us -50,000 on top. We got our pi right there, and then we're all of that being over 3. Luckily, this would have a common denominator of 3 already, so we wouldn't have to mess with that. So then bringing the tops together, those are like terms. So this is going to be -70,000 pi over 3. And they told us what this was going to be in the end, but if you didn't, you know, remember, you know, dV dt, the volume tells you it's going to be cubic units anyways, but the, you know, but like I said, they kind of told us, so this would be centimeters cubed per day. So as you go through here right now, what you would need on this is, first and foremost, you're really going to get 2 points for going through that whole process and just getting out that derivative. And then you're going to get your last point on this by making it all the way to the end and getting out your final conclusion for your answer here. So 3 points total on part D, giving us our 9 points when we add up the 6 we earned on A, B, and C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.